Welcome to the deep dive. Today, we're going to cut through some serious complexity in enterprise IT.
We really are.
We want to give you a shortcut, really straight into the future of networking.
That's the goal.
We're doing a deep dive into technical sources, all derived from this specialized guide, Hybrid Multicloud Networking for Dummies, Equinix Special Edition.
Right.
And our mission today is pretty straightforward. Pull out the concrete strategies, the infrastructure you actually need, and, maybe most importantly, the proven best practices this guide talks about.
Yeah, the idea is that you walk away knowing how to fix what is probably the biggest architectural bottleneck that companies are facing right now.
Exactly.
Yeah.
And just a quick administrative note before we really get into it.
Oh, right. The consents?
Yeah, you'll see when you access this kind of material, these specialized white papers, there are always legal consents.
Always.
This one requires the standard stuff, company email, your name, title, location, that sort of thing.
And they hold on to it for about 3 years. It's for service provision.
Right. So just something to keep in mind as we jump into the technical material.
Good call.
Okay, let's unpack this. Why this huge, aggressive shift toward a hybrid networking architecture? Is it just an upgrade, or is it something more?
It's way more. Because for most large companies, their network isn't an enabler anymore.
It's a blocker.
It's an active blocker.
Yeah.
And the sources we analyzed, they confirm the sheer scale of this problem with a really startling statistic from IDC.
Okay, what is it?
A full 72% of enterprises report that their current network design
72%. Wow.
actively hinders their ability to adopt new cloud services.
So it's not just slow, it's actually getting in the way.
That's the high-stakes context here. The architecture they have right now is creating friction. It's slowing down innovation. It's basically stopping them from capitalizing on the cloud investments they've already made. Their network is slowing down their business.
72%. So basically 3 out of 4 businesses are trying to drive innovation with the parking brake on.
That's a great way to put it.
So this hybrid multi-cloud networking thing, it's not just about connecting stuff. It's about systematically removing that brake pedal.
Yeah.
How do the sources actually define this approach?
Well, it's defined as the strategy that securely connects your private infrastructure, multiple public clouds, and those critical edge locations.
So bringing everything together.
Exactly. The goal is to stop treating these as separate islands. And the key outcome is that it unifies the entire network environment into what the guide calls a seamless digital backbone.
A digital backbone. I like that.
And that transformation has a pretty significant promise. We're talking boosting performance, noticeably reducing costs, and enabling secure, scalable connections across all those fragmented clouds and edge locations.
So creating consistency where there used to be just, chaos.
Precisely. Architectural consistency.
And here's where it gets really interesting for me. That unification, creating that backbone, is basically the end goal of future-proofing your network, isn't it?
It is. The guide promises that if you adopt these approaches and the 10 proven best practices it lays out, that's the path to making sure your architecture isn't obsolete tomorrow.
But you can't build a digital backbone out of thin air.
No, you cannot.
So let's shift from the big idea to the tangible tools. To build this global system, what are the key infrastructure components that the source material details?
Okay, so the foundation relies on a globally distributed physical platform. It spans 3 major regions: the Americas, EMEA, that's Europe, Middle East, and Africa, and then Asia Pacific.
Okay, a global footprint.
A global footprint. And you have 2 main types of physical infrastructure. First, there's the standard colocation. It's described as interconnection-ready infrastructure.
So it's a physical spot that's already optimized for high-speed direct connections.
That's it.
And then there's this term xScale. That name immediately makes me think of massive capacity.
It should. The sources specifically call it infrastructure that's designed to enable multi-megawatt AI-ready capacity.
Okay, hold on. Why do we need a separate designation like xScale just for AI? Isn't the regular cloud big enough?
That's the critical distinction. AI training, these huge large language models, they demand a level of power density and sustained compute that, frankly, standard data center racks just can't handle.
Not economically, anyway.
Not economically or even physically. So xScale removes that power and cooling constraint. It lets you house those massive data-hungry workloads right where the critical interconnection pathways are, right at the digital core.
So colocation is about being ready to connect, but xScale is about scale, density, and power. It's built for the next wave of computing.
Exactly. But hardware is only half the story.
Right. You need the software to run it.
The intelligence comes from the software-defined components that knit all this physical infrastructure together. And the sources point to three critical layers here.
Okay.
First, there's Fabric. That's the core software-defined interconnection layer. It abstracts the physical connection.
It makes it virtual.
Exactly. And second, you have the Fabric Cloud Router. This is the tool that gives you virtual routing with private connectivity across different clouds and your colocation on a global SDN.
A software-defined network. Okay, let's break that down. What does virtualizing the network actually mean for an engineer trying to deploy something new? Is this just about speed, or is there a bigger business benefit?
It's a huge win for agility and for cost control. Instead of, setting up physical routers, getting complex peering contracts, managing all these separate connections between, say, two different clouds.
Which takes forever.
Weeks, sometimes months. With the cloud router, it becomes virtual. You click a button, and secure private connectivity is established globally. Deployment time goes from weeks to minutes, and it helps slash those crazy cloud egress fees because you're using private pathways.
Okay, that makes sense. And the third element?
The third software element is Network Edge. This lets you instantly deploy virtual network devices, things like firewalls or SD-WAN gateways globally. You get resources closer to where they're needed immediately.
That virtualization piece clearly solves a lot of the complexity. But there's one other service mentioned that seems almost on the side, but I have a feeling it's critical. Equinix Precision Time. It's described as global and secure time synchronization. Why is time sync so important for a global SDN? Isn't that just, table stakes in the cloud?
This is where we move from just performance to things like regulatory compliance and auditing.
Oh.
If you're a global company running transactions, especially in finance or another regulated industry, every single action across your whole distributed architecture has to have a legally defensible unified timestamp.
Every action, from the edge to the cloud.
Every single one. If the clocks across your environments are off by even a few milliseconds, they call it clock drift, it completely kills data integrity. It makes correlating events unreliable and makes any kind of forensic audit almost impossible.
So Precision Time takes it from just a technical detail to a global compliance tool.
That's it, exactly. It's for global accountability.
Okay, this is incredibly important. So we've got the foundation, the infrastructure, the software. But the real reason we dug into this was the promise of those 10 proven best practices.
Right.
Let's deliver on that. What are, say, 4 of the most impactful strategies the guide recommends?
Absolutely. If the goal is solving that 72% problem we talked about,
The parking brake.
then these are the rules of the road. The first one is foundational. Adopt a cloud-adjacent strategy.
Cloud adjacent.
It means you have to stop backhauling all your traffic and controls to some centralized, faraway data center. Instead, you move your network controls, your security inspection points, next to the cloud provider using colocation.
Which instantly solves latency problems, right? You're literally reducing the distance the electrons have to travel.
Precisely.
Yeah.
Okay. Second practice is all about security in this fragmented world. Implement identity-based zero-trust security.
The old perimeter is dead.
It's dead. When your traffic spans multiple clouds and countries, it's gone. You have to tie your security policies directly to the user or the workload's identity, no matter where they are connecting from.
That sounds necessary, but also potentially really complex to deploy across all those systems.
It can be, which is why the third practice is so critical, and it ties right back to the tools. Simplify interconnection using software-defined routing.
So the Fabric Cloud Router.
This is where the Fabric Cloud Router becomes a practice, not just a product. The best strategy is to deploy these virtual connections rapidly, instead of waiting months for physical circuits or just, hoping the public internet works.
So you're turning weeks of provisioning into instant connectivity. The network becomes elastic.
Yes. And finally, the fourth practice is about the big picture organizational shift. Consolidate network and security functions. Stop managing your routing, your firewalls, your VPNs as separate hardware boxes. Exactly. The best practice is to deploy these functions virtually, remotely, using something like Network Edge. You reduce your physical footprint and use centralized management onto that one digital backbone.
So the hardware platform is global, but the control plane becomes unified and software-defined. That's a really elegant solution to the complexity.
It is.
Okay, so we've gone from the big problem to the specific infrastructure to the actual best practices. Let's zoom out again. We've talked about the how and the what. Let's talk about the why. What major business results does this unlock?
Well, it enables what the source material calls multi-cloud potential. When your network is agile and high performance, you can finally use cloud services for what they're actually for. Flexibility, scale, specific features, not just as another remote server room you have to manually connect to.
You can actually pick and choose the best service from any cloud.
Right. And this leads directly to the next 2 points, which are, I think, inseparable right now. Managing cloud sprawl in the AI era and identifying where the edge meets AI opportunity.
Okay, managing sprawl always implies a fear of runaway costs and complexity. How does this unified backbone help with AI data management, which is famously expensive?
Well, AI is the ultimate driver of data gravity, right? It needs to pull massive data sets off across regions for training and inference.
Right.
If that data movement happens over fragmented, high-cost public internet links, the whole AI project can become financially unsustainable almost overnight.
The egress fees would kill you.
They'd kill you. So by consolidating the compute, like with xScale and the routing with the cloud router, into a single, high-speed private backbone, you dramatically control those data egress costs.
Right.
And you guarantee the low latency you need for real-time AI at the edge.
So this is the architectural shift you need to handle the sheer scale and speed of modern AI.
It's the move from disconnected silos to a unified backbone.
So what does this all mean for you listening to this? I think this deep dive confirms that hybrid multi-cloud networking is no longer just a technical choice.
No, it's a business mandate.
It's a fundamental business mandate, and it's driven by the need to scale AI, manage this global fragmentation, and solve that problem of a network that's actively hindering 72% of new cloud projects.
That unification, breaking down the walls between private data centers, public clouds, and the edge. That's the key concept.
Absolutely.
And if we connect it all back, achieving what they call data center excellence and getting past these network limitations, it all hinges on this pivot to a global, software-defined, cloud-adjacent architecture. The guide provides the map, and the infrastructure provides the roads.
And as a final provocative thought for you to chew on, the source material focuses so heavily on this junction of emerging tech. We saw the emphasis on xScale for AI-ready capacity and that insight where edge meets AI opportunity. This raises a really important question. How fundamentally must an enterprise rethink its physical network layout? I mean, the actual placement of hardware, the flow of traffic. How much does that have to change to truly capitalize on this next wave of distributed compute? It suggests that scaling AI isn't just a software patch. It requires rethinking the physical geometry of your digital infrastructure entirely.
A really interesting point.
We want to thank you for sharing these sources with us and letting us take this deep dive into the future of network architecture. Until next time, keep digging into the sources.